Good morning and welcome to the session number 7 from the chapter of Semiconductor Devices and Circuits. The topic is the N Type Semiconductor, and this session is in a continuation of the session number 6 in which we have studied about the extrinsic semiconductors. So N Type Semiconductor is formed when a pentavalent atom such as the arsenic, antimony or the phosphorus are doped in the intrinsic semiconductors such as silica or germanium. So these are basically the two types of intrinsic semiconductors which are normally used in the electronic industries. So when this pentavalent element such as the arsenic, antimony or the phosphorus are doped in the intrinsic semiconductor, then an N type semiconductor is formed. And how it is formed? Here this is a pentavalent dopant atom. So here I have taken it as this is a phosphorus atom and this is a pentavalent dopant atom. This is also called the impurity. So and this dopant atom or the this impurity is surrounded by the extrinsic semiconductor atoms. That is, in this case I have taken it as silica. It can be germanium also. Now the pentavalent element, this is, or can say the pentavalent atom, has got 5 valence electron. This has got 5 valence electron, and the silica or the germanium, they have got 4 valence electron. So what happens is that 4 electrons, that is 4 valence electrons of the dopant atom, they bond with the 4 valence electrons of the 4 silica or germanium atoms which are surrounding this dopant atom. So what happens that one valence electron of the dopant atom is let free because it has got 5 valence electron. So 4 valence electron of this dopant atom, they bond with one atom, this valence electron bonds with one this valence electron of this silica atom. One valence electron of this dopant atom will bond with this one electron of this silica atom. One valence electron of this dopant atom will bond with one valence electron of this silica atom, and one valence electron of this dopant atom will bond with one valence electron of this silica atom. So in this way what happens, one free electron, one valence electron of the dopant atom is let free. So this is the free electron, and this free electron is weakly bound to the parent atom. Now this free electron is basically called the conduction electron, and the amount of the conduction electron depends on the concentration level of the dopant atom. So if I increase the concentration level of the dopant atom in this intrinsic semiconductor, then the number of free electrons can be made much larger than the number of holes. And the number of holes in the N type semiconductor is only due to the holes from the intrinsic source. So here in this case, since the electron, this free electron is the majority carrier, and the holes are the minority carrier, therefore in the N type semiconductor the number of holes is greater than the number of this free electrons is greater than the number of holes. So this is all about the N type semiconductor. In the next session, that is in the session number 8, I will be discussing about the P type semiconductor. So till then, have a nice day. Bye.